This is Mrs. Wainwright's Math Class, Chapter 11, Lesson 12. Find the volume of composed figures, Part 2. Today's learning target: by the end of this lesson, you should confidently be able to say, I can find the volume of rectangular prisms that are combined. Today, I'll be showing you a different way from what we showed you last lesson. You then can choose which way makes more sense in your brain, and that's the way you can always go ahead and tackle these problems. We will use the following videos to help us learn this lesson. Deborah Young, Volume of Complex Figures. Pay attention, there will be questions during the lesson.
Let's take a look at this example right here. The subtraction method. You can subtract the volumes of prisms formed in empty spaces from the greatest possible volume to find the volume of a composite figure. Here's a step 1. You have to find the greatest possible volume. In other words, you have to look at this as if you had the entire rectangular prism filled in completely. So we would have length times width times height of this rectangular prism. So imagine this is one gigantic rectangular prism completely filled in its entirety. So we would have length times width times height. So that would be 10 times 4 times 6. Our length is 10 inches, our width is 4 inches, and our height is 6 inches. Well, we know 10 times 4 is 40, and we would do 40 times 6, and this would give me a volume of 240 cubic inches. All right, so I'm going to write 240 right there. Now, step 2 is going to be where we're going to subtract the invisible portion right here. Here's the reason why. We found the volume of this entire rectangular prism, but as you can see, this portion right here is not really there because this is a complex figure. We have two rectangular prisms combined, but we're going to use a strategy of just find the whole volume of length times width times height, and then we're going to subtract this smaller portion. So now our job is to find the volume of this smaller portion. Now let's see what we know. We know that the length will be 8 inches, and the reason why the length has to be 8 inches is because it was originally 10 inches down here and 2 inches up here. And you know that 2 plus 8 would be 10. So we have 8 to be our length for this invisible portion of the rectangular prism. So I'm going to go ahead and write length times width times height here, and I'm going to go ahead and write 8 to be the length. Now let's find the width. Now the width on this one is actually going to be congruent with our other rectangular prism. Do you see how we have a 4-inch width here? Well, it's going to be congruent as well right there. So I would say my width is still going to be 4 inches wide. And now let's find the height. Now you can see we've already written in 4 inches, but I'm going to show you why. Up here, do you see how we originally had 6 inches? I'm going to put a 6 right there to show you why. Now remember, if you look right here, this is 6 inches right here, just like this top one shows us. We know 6 is right there, but if you look over here, this would also have to equal 6. And we already know 2's already been used at the bottom portion, so we have to say 2 plus what would equal 6. And I know this invisible portion would have to be 4 inches, and that's why we plugged in 4 right there for the height of our invisible rectangular prism. So that's why it has a height of 4. So now we have 32 times 4. Now I know 32 times 4 would have to be 128 cubic inches. So that would be the volume of my second rectangular prism, because remember, we had a length of 8, a width of 4, and a height of 4. So our volume was 8 times 4 times 4, which would give us 128 cubic inches. Now, the last step is we're going to subtract this invisible portion volume, which is like our rectangular prism B, from our original full greatest possible volume, which was 240. So we have 240 minus 128. And I'm just going to regroup right here, and I have 112. So our final grand total for this complex figure right here would be 112 cubic inches. Let's go ahead and try that strategy for number 2. Remember, our goal is to find the volume as if we had an entire filled-in rectangular prism. So I'm going to go ahead and find the volume as if it was one entire rectangular prism. All right, here we go. We're going to start off with length times width times height. Now, as you can see, I know that my length is going to be 14 centimeters. So if this is 14, we know this has to be 14. So let's go ahead and fill in this unknown portion right here. 6 plus what is 14? If you said 8, you are correct. So I'm going to put a little 8 right there just to help me for a future subtraction part. So we have our length times width times height. Now we've just discovered the length of the full rectangular prism would be 14 centimeters. So let's go ahead and plug in 14. Now let's find our width. Now, this might be a little bit more difficult because you see two portions. I've got 12 centimeters here, but then we have to come over to this portion right here. Do you see how they've given me a little helper? 4 plus 12. If we combine these two together, it would actually equal this full width. So that is 12 plus 4 to be 16. And we're going to put 16 down as our width. And of course our height is given to us right here to be 2. So I'm going to go ahead and put in a 2 for my height. So now to find the volume of this full rectangular prism, we'd have 14 times 16 times 2. So let's go ahead and work out 14 times 16. And when we do that, we have to show our work. I have 84 for my first partial product. I'm going to put down my spacer and erase away my 2 that I regrouped. And you should have 140 for your second partial product. And when you add those two together, you should have 224. Now remember, that's just going to be our base. So I'm going to write 224 right there for my 14 times 16. And now we have to multiply that by 2, my height, to be able to get the volume of this full rectangular prism. So we have 224 times 2, and that would be 448 cubic centimeters. Now that would be my volume of my full rectangular prism. So let's go ahead and write that down as 448 cubic centimeters. Now we're not finished though, because that's not the true volume. Now our next step is to subtract this invisible portion from 448. Alright, boys and girls, so what we're going to do now is we're going to take our formula, length times width times height, and let's see what we know. What we know right now is my length will be 8 centimeters, because remember, 6 plus 8 we found to be 14. So this invisible portion right here should be 8 centimeters. So I'll put in 8 for my length. Now my width, boys and girls, for this portion right here is going to be congruent with the width on the other side of the rectangular prism, 4 centimeters. Because remember, with rectangles, you have 2 sets of congruent sides. And my height will remain the same. Do you see how we have 2 centimeters here? It'll be the same right there. So I'm going to write a little 2 right there to remind us that the height will be 2. All right, we know 8 times 4 is 32. And we'll multiply that by my height to get the full volume of our invisible rectangular prism. 32 times 2 is 64. So my last step is going to be subtracting my invisible rectangular prism volume from my original full rectangular prism. So we would do 448, and we're going to subtract 64 from that. All right, 8 minus 4 ones is 4 ones. I can't do 4 tens minus 6 tens, so let's regroup. Borrow 10 tens. And we have 14 minus 6 would be 8 tens. And we have 3 100s. So our final volume would be 384 cubic centimeters would be our volume.
Please stop the video and complete worksheet number 1 right now.
Okay, I'm going to walk you through the formula that this would actually be if we actually were to solve it, if we were to do the subtraction method. Remember, we would have length times width times height of the original full rectangular prism had we created a full rectangular prism, which we will do together. And we're going to subtract it by the length times width times height of our imaginary rectangular prism that we will fill in this extra portion with right here. So let's go ahead and find the length times width times height of our full rectangular prism if we were to build it. I could see this full length is 8 inches. The width, as you can see, is 3 inches. Do you see right here we have 3 inches wide? And my height for this full rectangular prism would be 6 inches high. So we have 8 times 3 times 6. Now we have to subtract our imaginary rectangular prism. Now let's go ahead and find our length. The length for our imaginary one, remember, it's only going to go this far. It stops right inside here. Okay, so we would originally have 8, but we're going to shave off 1 inch. Now the reason why we're shaving off 1 inch is because this portion right here is 1 inch wide. So it would be 8 minus 1 would give me this portion right here. So I'm going to go ahead and write 7 inches for this inside portion. And let's find our width. The width right here is 3 inches wide. Okay, so if I look right here, my width would remain the same. 3 inches here. It's going to be 3 inches here as well. So my width is going to be 3 inches still. But my height, let's find the height. Now the height was originally 6 inches, but we're going to take off this 1 inch portion right here because now it's only this tall. Alright, so we have 6 minus 1 would give me this portion, which would be 5 inches. So my formula would be 8 times 3 times 6 minus 7 times 3 times 5. So let's go ahead and solve my original rectangle. 8 times 3 times 6. Well, I know 8 times 3 is 24, and 24 times 6 is 144, and that would be cubic inches. Now we want to subtract 7 times 3 times 5. Well, I know 7 times 3 is 21, so I have 21 times 5 to find the volume of my imaginary rectangular prism. So that would be 105. We will subtract cubic inches. All right, so now we have 144 minus 105. All right, let's go ahead and do this. When you subtract, you should have 39 cubic inches to be the volume of our complex shape.
Please stop the video and complete worksheet number 2 right now.
Now looking at number 6, what is the volume of the composite figure below? I would suggest that the method that we learned yesterday, which is adding the two combined volumes of two rectangular prisms, looks like it might be an easier solution to solve for number 6. Now, of course, if you feel comfortable with the method that I just taught you tonight, and you want to go ahead and subtract the invisible rectangular prisms that you can visualize right here, and of course that would be congruent, so you would have 2 of them. That's another method that you can do, and you can try on your own.
And this problem is really the perfect example to show you how you have to look at each and every problem individually and pick the method that you think works best for that problem. So the choice is yours, whichever one you pick. So now you can decide which way you like better, and that's the way that you use to solve the problems. However, if you like both, you can use it whenever it's best. Whenever you see one way as being the best way to solve the problem, that's the way that you'll use. Hopefully by now you can confidently say, I can find the volume of rectangular prisms that are combined. We will be practicing more in class. If you have any questions or concerns, please see a teacher. Good luck with this lesson.